Hello and welcome to Python for Beginners Python and Machine Learning, and we're doing meetup number 088. My name's Tim Cummings, and today it's the first Tuesday of the month, so we're going to be doing a session for absolute beginners. Now we do one of these every first Tuesday of the month, and this one is going to be probably the third in the series of getting started ones, but it's supposed to be for absolute beginners. So if there's anything you don't understand, please ask questions, and I can go into it in more detail. So I'll be listening on YouTube chat, and I'll also be listening on the Slack channel and the Learning to Code channel in Beginners Python. So today we're going to be using Google Colab, which means that you don't have to have Python installed on your computer. And in the meetup and also in YouTube, I've put a link to the Google Colab notebook that you can use. So it's got everything typed in for you, so you can just run along beside. And there's spots in there that you can do the exercises if you want, or you can just watch. What I would probably do. You can either watch it live, which means you can ask questions live, or you can pause and do the exercises, maybe even run it at faster speed to catch up to us if you've done the exercise, and so you can still stay semi-live and keep asking questions. Okay, so the first thing to do is to open the Google Colab notebook. And so if you click on the link, that will open it for you. And for me, it's opened it in the wrong account, so I'm going to go in to my Pythonator dev account. Okay, so this is the notebook. You won't be able to make any changes as it is, but you can save a copy to your drive. And then you'll be able to make changes. So you see it's currently called Meetup 88 Coding Introduction, and I'll say copy to drive. And now it's called Copy of Meetup 88 Coding Introduction. And so now you can make changes and save your changes and come back to it later. All right, so you'll need a Google account to do this. Google Colab is great for interactive use, and so it's used a lot in data science. It's not so good for scripting and building apps, but we're right at the beginner stage of Python at the moment, so we're not going to be building big applications, so this is going to be fine for us. If you do want to install Python 3, you can install it from www.python.org. And that's if you want to run Python on your own computer. Alternatively, you can install Anaconda, and Anaconda is just like Python, but it includes many third-party libraries. I'd also install a IDE such as PyCharm Community Edition, which is free, and that gives you a lot of hints while you're writing the code to help you do that. Okay, so you can see this first block of text up here has got a rectangle around it, and that's called a cell in Google Colab. So the cells can contain either code, or they can contain formatted text using the Markdown language. So if I double click on this, you'll see this is the Markdown language that I used to create that cell, and on the right here you see what it looks like. So this is quite a good way of doing reports. Now to enter this cell, I can do Shift Enter, and then that calculates the formatting and just shows that cell. And now it's taken me down to the next cell, and so you can see the active cell is got this rectangle around it. Now the different ways to write Python, it's the same language in all cases, but today we're using Google Colab, which uses Jupyter Notebooks, and Jupyter Notebooks is really an extension of IPython or interactive Python. So you may have heard of those terms before, and that's so you really they're almost interchangeable, the IPython and Jupyter Notebooks these days, and Google Colab is one of the places that you can run Jupyter Notebooks. If you want, you can also see just a straight Python version of this notebook, and it's available in our GitHub repository, and this is the URL to get there. And if you look in this GitHub repository, you'll see that URL will take you to the online folder where we've been putting all the code for our online ones, and we'll look up Meetup 88, and there's the code. So if you want to download that one, just convert it to raw, and you'll be able to, that's a straight Python file now, so you can just download that one and run it on your computer. But today we'll do everything in Google Colab, so you don't even need Python installed. So how to use Google Colab? You can type into any of these cells, you can press Shift Enter to execute the cell. You've seen an example of markdown text, and now we're going to get on to Python code. So this is an example of some Python code. It's very simple code. It just uses these hash signs to make comments, and comments don't do anything in Python, which means they just anything, you can type anything you like after the hash, and it's really just a comment for the programmer to understand what's going on. Now on this, in this cell here, we've got a single question mark, and that's an IPython thing. For bringing up help. If you're using the Python console in your IDE, such as PyCharm, then use help with parentheses to do a similar sort of thing. So if I press Shift Enter now, it's going to run that question mark, which is going to bring up help for the for Google Colab. Now the very first cell you execute in Google Colab is going to take a little bit of time, which it did, and then over here on the right you can see the help that it brought up. So it's talking about IPython, just like I said, interactive Python, and different things that you can do. But really the most important one is using a question mark and a word to get help on a particular object, and you can also do double question mark on words to give more information. Alright, so let me know in the chat if you had any problems getting that help to come up. I'm just going to hide it by clicking the X. And now we're going to run our first Python command. So this is a Python command to print the number 5. And so we just run, it's actually called a function, a built-in function print, and in parentheses you put what you want printed. In this case we're going to put the number 5, and so now if I run that, I get 5. Good. It's good to see Mi Zhang has said all good, so obviously he got his running. Alright, so here's the cell of Python code with the play button here, and then here's the output for that cell, and it's got the number 5 there. So you can see each one of these cells, as we run them, they get a number, so we can tell what order they got run in. So this was run first, this was run second. Alright, so print 5, that works in all versions of Python. If you're using IPython or Python console, like this Google Colab, the interactive Python, you don't even need to put the print statement in. You can just put an expression or something that you want to display, and it will display it for you. So if I do Shift Enter, I'll now see the number 4 come up, just like we saw number 5 come up when I did print 5. You can put more than one command in a cell, and they'll be executed sequentially. So if I said print 4 and then print 3, I'm going to get the two numbers display, the 4 and then the 3. Unfortunately, if you're in IPython, only the data on the last line is displayed. So if you need, so let's have a look at what that looks like. So I've put 2 and then 1, but it really only looks at the last line, which has 1 as the result, and so 1 is what's displayed. So if you need to have more than one line displayed, you'll have to use print statements even in interactive Python. Okay, now you can see I've left an empty cell here, and we've got a task here. In the empty cell below, write a Python program to count down from 5 to 0 on separate lines. Okay, so we've seen examples. We saw an example of printing 4 and 3. So if we wanted to do that for 5, we can just type the commands in. So it's pretty simple. Have a go at typing, and if you get this working, then you know you've really written your first short Python program. So I ran that, and I get 543210. I might just add, while we're looking at these cells here, you can do things like insert extra cells above and below. So if you want to insert a code cell, you do a Control M and B, and that'll create a new cell below the one that you're currently in. Control M and A will put a new cell above the one that you're in, or you can just choose the menu items from here. Also have a look in Tools keyboard shortcuts, and that'll show you all the different commands that you can do in Google Colab. So here's the one I just mentioned. Control M and A will insert the code cell above. Control M and B inserts the code cell below. And if you're on a Mac, that'll be Command M A and Command M B. You can even make changes to those, but I'll just cancel that. Right, so remember, is there anything that you don't understand, make sure you ask in the chat, because I'm sure if you don't understand it, someone else will not be understanding it. Okay, how to comment out the codes. So which codes are you wanting to comment out? So I just selected a couple of lines there, and I did Control // and that just commented out those lines. So now if I run it, it will just do 3210. And that was just on the selected lines. And if I do Control / again, that gets rid of the comments on those selected lines. If I do Control A, that will select all the lines, and I could comment that out. So with these cells, you also don't have to run them. Running each one is optional, so I didn't run this one because there was nothing really in there to run, so it doesn't get a number because I didn't run it. I can also that can delete the cell, yeah, and I can delete the output of running it. So if I had it like that, even though they're not commented, if I don't run them, I won't have any output from them anyway. Okay, so I've given you a task here. I left a blank cell to do it, and what I'll be doing is I'll be working through an easy solution to all those, and then I'll give you a little bit more complicated solution is actually in the cell in the work notebook. And so this is solution 1. So I'm putting some more print statements, and this time I'm doing it in text rather than numbers. Now to do text in Python, they're called strings, and we have to designate them as strings by putting quotation marks around. So you can use double quotes, you can use single quotes, and you can even use triple double quotes or triple single quotes, and they're all pretty much equivalent. You choose which one you want to use based on what's actually in the string that you're trying to do. So if If you're trying to put a single quote somewhere in the string, then you wouldn't use single quotes as the string designator. You'd use double quotes for that. The triple versions are useful if you want to put line feeds in those strings as well. Okay, so let's run this one and see what it looks like. Shift enter, and we can see it prints out solution 1 counting, and then 543210 all in words. Okay, so I mentioned it's called strings. In Python, it's referred to as str as a string. So you can find out the type of any of these bits of data by using the type function. So if we say we put a string inside the type function and we run that, it returns str, which is Python's way of saying string. Similarly, if we had a number, as we had before, like 123, the type of that is an integer, which Python calls an int. Python can also work with real numbers that have a decimal fraction. So for example, 123.45, and we want to find the type of that, and that's a float. And it's called float because it's a number with a floating point. It's a floating point number. Now, my getting started one, we covered all of this in a little bit more detail, but I'm just recapping over it. So I'm going pretty quickly, but if there's something that you want to me to go into more detail, I'm happy to do that. Python can do arithmetic on numbers using these operators. You've got plus, minus, the asterisk is for multiplication, slash is for floating point division, // is for floor division, percent is for modulo, which is the remainder after a division, and ** is the to the power. When it's doing these arithmetic expressions, it uses order of operation, so it does multiplication before it does addition. So 1 times 2 plus 3 times 4, it'll do 1 times 2 is 2, 3 times 4 is 12, 2 plus 12 is 14. So if I run that, I should get 14, and sure enough, it gives me the answer 14. Now, any of these bits of data, we can store them in memory, and when you do that, it's called creating a variable. And the variable is a place in memory where the data can change, and that's what variable means, is changing data. So we can put it in there, and then we can make it change. So, for example, if we wanted to store the number 5 in a spot in memory, we make up an arbitrary name for it. So we'll just call it A, and notice that's A without quotes around it. So if it had quotes around it, Python would think it was a string. Because it hasn't got quotes around it, Python's going to know it as a variable or a function or something like that. So A equals 5 has got a memory location, and it's put the number 5 into that memory location. So now if we want to print out what's in that memory location, rather than putting 5 in there in the print statement, we can put the variable name, which is A. So if I say print A, it'll now print the value 5. So here I put a number into A. I can also calculate an expression and put the result of that expression into variable B. I can have other expressions that are made up of existing variables. So A's got 5 in it, B's got 2 to the power 32, and C's going to have 5 times 2 to the power 32. And I can print all those 3 values using this form of the print command, which is just puts commas between the variables. So we can see A is 5, and then it leaves a space between the two. B is going to be this large number here, and then C is going, which is about 4 billion, and then C is going to be 5 times that, so it's about 21 billion. All right, so programming would be very cumbersome if we had to type a line for every command we wanted to execute. So if we can repeat commands, we just have to type them once, and they'll run over and over again. So if we can see parts of our code where repetition is useful, then we can put that bit of code into what's called a loop. The two sorts of loops that you can have in Python are the while loop and the for loop. So here's an example of a for loop. So what a for loop does is it creates an extra variable. So in this case, it's created one called z. So we've just put in the variable name there, z, and we get a sequence of values that we want z to have. So the first time through the loop, z will have the value 5. The second time through the loop, z will have the value 4. The third time it'll have 3, 2, 1, etc. And then anything that's in the loop is going to be indented. Now the indentation doesn't have to be anything special, but you'll find that most programmers around the world will use 4 spaces. And you just have to be consistent with that throughout your program. So you can't mix tabs and spaces. So you could use one tab there if you wanted, or you can use 4 spaces. But if you choose tabs, you have to use tabs everywhere. And if you use spaces, you have to use spaces everywhere. Now I've chosen 4 spaces on this, and that was actually a setting in my workbook, my notebook. The default in Google these days is 2 spaces, and that will work fine. So I'm presuming you're going to have 4 spaces because you've got a copy of my notebook there. Right, so everything indented is what's repeated in the loop. So this loop is going to happen 6 times because there's 6 values there. And it'll run those 2 lines and then go back up and run them again with a new value of z, then run them again with a new value of z. So that's all that's in the loop. Then the last line is not indented, and that's how Python tells that the loop has ended, is because you've stopped indenting. And this is different to just about every other programming language that I know. Usually they use curly braces or something to show you what's in the loop and what's out of the loop. But here, because of the indentation, it means it's really important you get your indentation correct when you're writing Python code. But it also means your code is really clean and easy to read. And that was a prime objective when they designed Python. So let's run this code with Shift-Enter and see what it looks like. So the first time through the loop, it printed the value 5, print z, and then the second time through the loop, z had in their value 4, so print z printed out 4, 3, 2, 1, 0. Now this line above it, total plus equals z, what plus equals does is it takes the existing value of total and adds the value of z to it. So total has an existing value of 0, and now it'll be the first time through it'll have 5, and the next time through it'll have 9, and then 12, and so on. So after adding up all those numbers, we can print what total is, and it says the total of the above numbers is 15. Okay, so task 2 is rewrite the loop to show a running total as it loops through all the numbers. Okay, so I'm just going to copy and paste that code, and really what all I need to do now is put a total. Right, so I've got a question here. Print function will add a space at the end of the expression. So not really. It does add a space. So see, I'm hovering over print at the moment, and it's showing up the help for print. So print is got a value followed by a comma, and then ... means several other values. And then it's got these other arguments, and the first one is separator equals, and it's a space. So that means that if we want to separate these values with spaces, that's what the default separator is going to be a space. But we can override that if we want, and I'll get onto that later. But seeing you've asked the question now, let's put a separator in this one, and we're going to put, I'll use single quotes here for the string, and in the string I'll put a colon rather than a space. So now when I run it, It's Z is 5. There's no space, but there's a colon between each one, and then another 5. 4:9, 3:12. So, and you can even put more than one character in there if you want. So I've put a spacer there of colon dash colon. So that's how to change what the separator is between values in print. All right, so I did that solution using a for loop. Here's another solution using the while loop. So how while works is you have the while statement, and then you have a condition that evaluates to either true or false. And so while that evaluates to true, it'll keep doing the loop. So hopefully something inside that loop is going to change the result of this expression. So eventually it will, the loop will come to an end. And if it doesn't, then you're going to have an infinite loop, and that can be a problem. So we've set Z to be 5 to start with. While Z is greater than or equal to 0, so 5 is greater than or equal to 0, that's true. It'll go through this, and it'll add on to the total, and it will subtract 1 from the value of Z. And it'll keep doing that till Z equals 0. When Z equals 0, it'll be the last time it goes through, then Z will equal -1. When it goes back up to the loop here, it'll evaluate that expression and come up with the value false. So we go, okay, we're not going to loop anymore. So let's have a look at that. The number 5 running total 5, and all the way up to number 0 running total 15. All right, now I'm making changes to this copy of Meetup. If you're having trouble typing my stuff in, I can share that with you. So you can load this in another tab in your browser. So we want it, anyone with the link can copy this, and so copy the link. And as you, the link will stay the same. So as you refresh the if you refresh this page, you'll get all the latest stuff that I've typed in. All right, so task 3, write a loop which counts up from 1 to 5 and displays the factorial of each number as it goes. And factorial is just, factorial of n is just 1 times 2 times 3 all the way up to n. So let's start off with factorial equals 1 for z in, now I've been using sequences using tuples, which have got these parentheses, but I can also use a list which uses square brackets. Doesn't really make any difference in this situation. Factorial times equals z, print z, comma, factorial. So you can see z is 1, factorial is 1. Z of 2 has factorial 2. Z is 3, factorial of 3 is 6. Factorial of 4 is 24. Factorial of 5 is 120. So that's all well and good. But as these sequences get longer and longer, it's going to get quite cumbersome having to type all these numbers in. So it's such a common thing. Python provides a range function. So range gives you a starting value and a stop value, and it'll go from the starting value all the way up to, but not including the stop value. So this will go from 1 to 19 and not do 20. So let's have a look at how that works using the range function. And as you can see, these factorial numbers get very big very quickly. And there's really no limit on how many digits you can have in your integers. So this is another thing. You don't have to worry about whether they're 32-bit or 64-bit. They're just as long as is required to store all the digits that you need in your integer. So I've seen people have programs with thousands of digits, which you would use if you were doing something like calculating pi to 3,000 places or something like that. Okay, so I've got a question here. What's the difference between using parentheses and using square brackets? So what I'll do, I'll create a couple of cells above the one I'm in, up, and I've pressed the wrong key. So let's try bring that back, and I'll bring back the other ones that I need. Yep. So it's Control M above, Control M above. Okay, so this is called a tuple. And so if I wanted to find out what the type of my variable t is, it's called a tuple. And if I say L equals square brackets 1, 2, 3, and what's the type of that? And that's a list. So tuples and lists are very similar. They're interchangeable in a lot of cases, but the difference is that tuples are read-only and lists you can change. So say for example in my list here, I could say I want the last element, which is its 0 index, so the last element will be 2. I want it to be 4, and then have a look at what's in L. And so my list, it started off as 1, 2, 3, and I changed the value at index 2, which is this value, to a 4, and then I displayed the results, and it came to 1, 2, 4. So if I tried the same thing with a tuple, because tuples are read-only, I can't do this. So if I tried it, I would get an error. Tuple does not support item assignment. So there are times when it's really useful to have a read-only variable. I can tell you now, dictionary keys have to be read-only. So you can use tuples as dictionary keys, but you can't use lists. So wherever you can, try to use tuples until you find out that you actually do need to make a change, and then you can use lists. And you'll find that there's a few subtle programming errors that can be introduced in your code by using these, what they call mutable variable data types. And so if you avoid them, then you avoid those subtle programming errors. But of course you do need them. You do need mutable types sometimes, so that's when you would use them. Let me know if that was clear or not. Okay, so task 4, display the first 20 numbers in the Fibonacci sequence. So Fibonacci sequence, it starts off 1, 1, and then every number after that is equal to the sum of the two previous numbers. So 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, 5 plus 8 equals 13. Okay, so we want to, we're going to start off with, let's use F1 to store the first value. F2 is also going to store the second value, which is 1. And then for I in range, I'll just guess 20, F3 equals F1 plus F2. All right. So now I can Well, I'll print F1 because that's the value that I want. I'll calculate F3. Now that I've calculated F3, I've got to shuffle everything back. So now I can say the new F1 is going to be equal to the old F2, and the new F2 is going to be equal to the old F3. So there we go, 1, 1, 2, 3, 5, 8, 13. And so, yep, that's calculating the Fibonacci sequence for me. But I'm only ever printing out F1, and I needed to have all these other variables just to keep track of the values for this to work. So let's have a look at the solution. One of the things that you can do in Python is have multiple assignment statements on one line. So rather than saying F1 equals 1 on one line and F2 equals 1 on the next, I can say F1 comma F2 equals 1 comma 1. So I put all my variable names on the left and all my values on the right, so all separated by commas, and it just assigns, like the first one to there goes to the first one there, the second one goes to the second one. Okay, and where that is really useful, say for example this Fibonacci sequence, is that I don't need now an F3, because I can assign F2 to F1 and F1 plus F2 to F2, because it calculates all those first and then assigns them to the values, to the variables on the left. Now I needed, in my code, I needed to store the value F3 in here before I changed F1 and then changed F2, so that I didn't lose that F1 and F2 to calculate F3. So you can see it's reduced my number of variables, reduced a line of code. So let's run this, and so I've been playing around with the print statement here as well. Rather than printing each number on a new line, I've decided to change the default end character from a new line to a space, and therefore it's put just a space between all the numbers and not a new line, which is really useful for this case. And then at the end I do another print statement, and this one I didn't put an end on it, so it will print a new line. So that all that'll get printed and then a new line. Very good. So task 5, count down in steps of 2.25 from 10.5 to -3 inclusive. Okay, so I think for this task I'll use a while statement. So let's say I'll use Z again. Z equals 10.5 while Z is greater than or equal to -3. Print Z and then subtract 2.25 from it. And there we go. So 10.5, 8.25, 6.0, 3.75, 1.5, -0.75, -3. So that's an answer to that task. So some people doing this would go, oh, it'd be good if we could use the range function in a for loop to do counting like this, because there's a fixed interval between each one. And that's true, but range only works with integers. So we would have to convert all of these to integers and step through using integers and then divide by the lowest common denominator to convert them back to fractions. So to do that, we could work out the lowest common denominator of our three numbers, 10.5, -3, and -2.25. The lowest common denominator is 4. So we could multiply each of those numbers by our lowest common denominator to get just the numerators. And even though they're an integer value, they started off as floating points, so they will still be a floating point number, and range needs them to be integers. So to convert between any data type, you can use the name of the data type and parentheses around it. So int, and a number will convert it to an integer, and we'll actually truncate it if required. So int of 10.5 times 4 is going to be 42, and so that'll be the numerator. So when you use the range function, it has a start, a stop, and a step. So the start value, the stop value, and remember it goes up to, but not including the stop value, and we're heading down. So if we want to stop it after -3, we want to stop when it gets to -3 and include -3, then we have to go further than that for our stop value, and then our step is how much we're going each time. And so the step is our -2.25 times the lowest common denominator. So if we run this, we get the same answer. So that's a good way of doing it. Some people really want to use the range command. So NumPy provides a command called arange as a function. So I've just brought that up in the reference. NumPy is a third-party library that a lot of people use in data science. It uses start, stop, and step, but they're allowed to be floating point numbers. But it says here, when using non-integer steps such as 0.1, the results will often not be consistent, and so it's better to use NumPy linspace instead. So have a look up the documentation on linspace if that's what you're trying to achieve. Alright, so what I'm printing out here is I'm printing out x divided by the lowest common denominator. So 42 divided by 4 gives me 10.5. But I'm also showing you how to use format strings. So a format string is any string, which is designated here by the double quotes, that's got an F out the front of it. So the F says it's a format string, and then when you've got a format string, anything inside the string, you can put these curly braces in, and the curly braces will evaluate an expression and then print the result. So it evaluates x over LCD and then prints it. Now I've also put in a colon here and some formatting information. So the formatting information I put in, as I said, when it prints it, I want it to be 7 characters wide. I want it to have 2 decimal places, and I'm telling it that the value that it's getting is a floating point number. And so that's how it's managed to line up all the decimal points there. So I'm just throwing this in. That's a more advanced topic, but just if you see them now, you'll start to get familiar with these format strings and gradually start to introduce them in your code. Alright, so remember on the NumPy page they said using floating point steps such as 0.1 can have a problem. So let's try that. Let's use a step of -0.1. So we're going to start from 1 and go down to 0 in steps of 0.1. So what do we get when we run that? Well, it starts off okay, 1.0, 0.9, 0.8, but then we're starting to get these rounding errors, and the rounding errors are caused by the way that floating point numbers are stored in binary. Our timer's off, so thanks for joining us today. This video's recorded, so you can always come back to it another day, but you obviously can't ask questions. Although if you really want to ask questions on the Slack channel, feel free to do that, because I can answer it, or someone else as a member of the Beginners Python group can answer it. Okay, so here you can see the errors just accumulating until by the time we get to 0, it's 1.38 by 10 to the -16. So using the lowest common denominator approach solves that problem. So that's one way. You see, that's just, I'm not hiding any rounding errors in by using print formats. I've got no print formats there. It's just printed at every calculation. It's got integers in the loop, and it's only at the display that it's converting to floating points. We didn't have those problems when we were counting down by 2.25, because the 0.25 is a power of 2. It's a quarter, so that's 2 to the minus 2. So that can be stored exactly in binary, but 0.1 can't be stored exactly in binary, so that's when you get problems. All right, we're going to have a look at some of these data types. Lists, we had a quick look at one before. So here's another list. It's an ordered collection of data types, data values of any type. I've got them all as integers, but they can be mixed. You can have integers and strings and floating points all in the same list. And when it prints out, that's what we see. You can create a list. So there's an empty list, it's just 2 square brackets, then you can keep appending to a list. So because lists are mutable, you can do that. But you can't do that with tuples, because tuples, once you've created it, you can't change it. Oh, there we go, there's a list with 30 values in it. And some of the things that you can store in lists, like I say, you can store all sorts of objects or values in the list. So here's an example. Rewrite the following code using nested loops. So let's run this code just to see what it does. So it's looking at different values of range. So we've got range of 4 is 0, 1, 2, 3. So that's, we're only providing a stop value. So it assumes a start value of 0 and a step value of 1. So it'll go 0, 1, 2, 3, and that's useful that they're actually, we said the number 4 and there are 4 values. If we went from 2 to 5, we get 2, 3, 4. So it starts at 2, goes up to, but not including 5. So we get 2, 3, 5. And that's this little bit of code here that's doing that. Right, so I'm going to write some code that will make this a little bit easier. So let's create a list, and I can put any sort of thing in my list. I'll call it LST. So be careful when you're creating lists, don't ever call it LIST, because LIST is a built-in function for creating a list. And if you call your list LIST, then it will stop this function from working. Okay, so list is a new empty list. We can do that, or you can. I showed you before creating with square brackets, but we can also create it using this list function. And I can put range values in there. Range 2, 5. So range is a function, returns an object, and that object we can store in a variable, and we're going to store it in this list. That'll do for now. So I can, for range in my list of ranges, I'm going to print the range, and I'm going to print, so we've done that, we're printing a range, and we're printing the end character as a space. And now we're doing a nested loop for I in range. Print I, and once again I want the end value to be a space, and then after that loop I'll just print a new line. So let's run that, and I've got an error. List takes at most one argument. Yes. So let's just use the I could have created a tuple there and then passed that through as a list, and that would have converted the tuple to a list. But that doesn't seem, when you've got more than one value, it doesn't make much sense to use the list function. So there we go, range 0, 4, 0, 1, 2, 3, range 2, 5 is 2, 3, 4, range 3, 14. Now I had to put an extra print statement there to print a new line at the end. If you look at how I did that in my original, I did several ways of doing a new line. I used a \n as one way of doing a new line. I could have used these a string with triple quotes, and then you can just type a new line inside the string. And then most of the time, I was just using new line characters. So \n means new line. And this was the other option, is just use a print statement. So let's have a look at our solution. This one I created a tuple of ranges, but I didn't use the full range object there. I didn't call that until inside the loop. So I've got a function range that can take several arguments, and I've got those arguments in my all of these lists. So how do I pass them through? So the first, say we'll look at this one, the 2, 5, range args is going to have the values 2, 5 in it. So I want them to be split up and placed as arguments in this function. So what I do is I put an asterisk at the beginning, and the asterisk means explode the list and place each item in the ordered argument positions. So this is getting a bit more advanced. Like if you don't understand that, I wouldn't worry too much. It's a more advanced way of passing arguments, but I'll show it to you now so you can see that's a thing that can be done. So if we run that one, we can see how they all display. What's useful about these, you'll notice 12,3 doesn't display anything because it assumes the stepping is going to be positive, but the starting value is greater than the finish, so it just displays nothing. So if you really want to go backwards, you have to put in a negative step, like in this case -1 or -3. All right, now you've seen we've got a bunch of code here that gets repeated every time. Now this is okay if we had to do it. It was all in this loop, but if our code somewhere else in our code also wanted to do these same lines, we'd have to then type them out again. So this is where we use functions as a way of using the same bit of code in several parts of our long script. So to define a function, you use def, which is a Python keyword, to define it, and then we give it a name, and then we open parentheses, and inside the parentheses we put the arguments that we want to call on the function. So you've seen other functions we've been using like print and type and range, and now we're going to create our own one called display range, and it's going to have a single argument that we'll call r. And it's just going to do those lines of code that we were looping over. So now I can, once that function's defined, I can call the function by doing the function name and then putting the arguments into parentheses. So let's try that. So display range 4 shows range 0, 4, and the answer is 0, 1, 2, 3. And range 12, 3, -1 counts down from 12 to, but not including 3, in steps of -1. And so we could have, so rewrite our loop from before, but this time calling the function. I'm not going to bother doing that one because the answer's pretty straightforward. For range args in tuple arg ranges, display the range and explode range args. And that just runs as before, but just in 2 lines of code because we're using our defined function. Now you see how I've my variable names, it's all in lowercase, and I use underscores between the words. So this is the current way in the Python guidelines for naming variables. You'll see some really old code that uses camel case, which means it would be they'd have no underscore and they'd have a capital R for your variable names. But these days this is the preferred style, so that's what I'd recommend to use. Tuple ranges is a variable. Remember, it was defined in a Jupyter Notebook cell way up above, but because that got executed, then this Jupyter Notebook still remembers the value of that variable and can use it in this function. Similarly, the function was defined before, but it can still be used here. So let's show some other functions. I'm going to write a function here called show time that takes no arguments. And what show time is going to do is going to print out the current time. Now to do that, I'm going to use a standard Python library that's not available to me in this in the standard Python environment. I have to import it. So there are some libraries that are third-party libraries, so you can import them, but you have to install them first. But datetime it comes with Python. It's just you still need to import it. So it's called a standard library, but it's not a built-in library. So the name of the library is datetime. In this library, there's a class called datetime.datetime, which is a bit confusing. But in that class, there's a function I can call called now, which returns an object of type datetime.datetime, and which stores the current time in it. And then because it's an object of datetime, I can call a function on that, a method called string format time, and that can format it in however I want to format it. So I'm going to format it like this and run that. So see if you understand what's going on here. So we're calling the now function in the datetime class in the datetime library, and then formatting that this way. So we're going to say year colon, and then %y gets substituted with the actual year in 4 digits. Percent lowercase m is the 2-digit month. %d is the 2-digit day. Hours, minutes, seconds, microseconds. So that's a function that does something. And our previous function also did something which was just print, but it didn't return any values. But we can return values. So let's write a function that's going to return all the time zone regions that we can use. So to do this, we're going to use a Python library called PyTZ or TZ, and it's not a standard Python library, so you will need to install that. So if you just have installed Python from python.org, you'd need to run pip install and PyTZ to install it. However, Google Colab includes all the Python standard libraries plus all those that are in Anaconda. So if you've installed Anaconda on your computer, or you're using Google Colab, then you don't need to do any additional installation to use the PyTZ library. That's just about libraries. Okay, so here's our function time zone regions, and you'll see the last line of that is to return the sorted regions. So what I'm doing, I'm creating a set. Okay, so I'm introducing a new data type here. So set is like list and tuple, but what's different about a set is that every value in a set is unique. So if I add a value to a set that already exists, it doesn't add it again. It will only have a single value in there. So this is good for me. I'm going to loop through all the time zones that exist, and I'm going to find the region. So let's have a look. I'm just going to do Control M above. I haven't imported PyTZ yet, so I'll do that. Import PyTZ. And let's just have a look at these time zones. So colon, you put the colon when you're about to have an indented code block. So remember that when we define functions, you put a colon there, and then the rest of it's indented, and everything that's indented is included in the function. And then when the indent is removed, like we're using show time, comment indents are ignored, but when we go to show time, that's not indented, so that means that's not in the function definition. So similarly in loops, the colon, we're about to start a code block which is indented, so because the colon was there, when I press enter, Google automatically puts in an indent for me. Print time zone. So you can see here, these are all the time zones we're going to get, and it's probably scrolled them. Yeah, scrolling, so we can see what they look like. So here, Australia, Brisbane is a particular time zone. All right. So time zones is a list. I might be able to just slice that. Yep, so I'm just taking the first 10 items of all time zones by using a slice here. So that's really 0:10. Says take everything from 0 to 10, not including 10. The 0 can be default, so I could leave that out. And it gives me the first few there. So time zone is that now. If I want to find if there's so times TZ is a string, and I want to do a check to see if there's a slash in that string. So let's have a look. If I say slash in TZ, and actually I'll do TZ. So here I'm going to output two values on the same line. Yep, that'll do. So is slash in TZ, that's true, and the value of TZ was this string, Africa / Bissau, so you can see there was a slash in there, and so that's how I can tell, is there a slash in there. Now some of them, if you went through all that list, you'll see they didn't have slashes in there. I think the New Zealand time zone, because there's only one time zone in New Zealand, they don't have to split the region up into the different areas. Okay, so if there's a slash, then I want to find out what the index of that slash is. And I can do that by saying tz.index, and index is a function on a string to tell me where the slash is. So it's got an index value of 6. So if we look at here, 0, 1, 2, 3, 4, 5, 6, and we're at the slash. Okay, so then I want to slice that time zone up to, but not including the 6. So I can do that. And what do I get if I do that? TZ and do a slice up to, but not including 6. And that just gives me Africa. So Africa is the region that I want, and I'm not interested in the areas within each region at this stage. the zones in the region. I'm not interested in them. Okay, so that's how I came up with this code here. I look for the slash. If it doesn't exist, I just put the time zone straight into my set. If it does exist, I put it in there. So like Australia's in there several times, Africa's in there several times. It's going to keep adding Africa into regions, but because regions is a set, it'll only keep it once. So let's have a look at what we get when we run this code. There we go. Africa's in there once, America's in there once, and this has all been sorted alphabetically using the sorted function, which is a built-in function in Python. Australia's in there once, and we'll just check if New Zealand got in there. There's New Zealand, and there's another area called New Zealand-chat. So I'm not sure what that is, but that's going to cause us problems. So define a function which takes one argument, the region, and returns the time zones in that region. Okay, so we're going to define a function, and we want to find the time zones for the region. Okay, and we'll just have the argument as region. Okay, I'll just so we'll just loop through all the time zones. And so if we just check if time zone, and it's got a time zone to string, so it's got a function called starts with. So if time zone starts with region, then, and what am I trying to do? Returns the time zones. I've got to add it into a list. Okay. Append time zone. So I better create an empty list up here. And then at the end of my function, I'll return that list. Okay, so let's try calling this. Zones equals time zones for region. Let's try Australia. For Z in zones, print Z. Okay, so that's showing us all the time zones in the region Australia. So that looks like it's working. So let's try our code for New Zealand. See, that it didn't work. We got New Zealand and New Zealand chat. So that's what I was saying before, is it's not going to work. So let's have a look at the solution and how we got around that problem. So we defined this function here, region for time zone. So that's really replacing the code that we did before. But by defining the function here, we can then use it in several places. So we can use it in the first, in the code that gets all the time zones for a region, and then we can use the same function in the code that returns all the regions. That returns all the regions. Okay, so remember our code before that returned all the regions. It was quite a few lines. I've shown you how to, and this is a fairly advanced topic, so don't feel bad if you're an absolute beginner. Okay, should return need to be indented is the question, and yes it should. I think I've indented it. If return is not indented, then it will be outside the function, and return doesn't mean anything outside of a function. Okay, so time zone regions, remember our code from before to do the time zone regions. That code can be written in this way. So what we're doing, the curly braces means create a new set. I'm going to copy the code from before so that we can see how we did it. So I'll just copy this. And I'll stick it above. So regions equals set. This is what this does. We put the curly braces here. That's a way of creating an empty set. For time zone in Pi time zone, all time zones. So we put that loop there inside the set. And then we calculate the region for that time zone. And we've put that into a function up here. And then we've sorted it. And then we've, rather than, here we've sorted it and put it into a variable. And here we've put return, and we've returned the whole thing directly without storing it in the variable first. So it just saves another variable name. And so we managed to compress it all down into one line of code to do what this function here did before. So don't try to remember this bit straight off, but I'm just letting you know that it exists, and what it's called set comprehension. And similarly, you can do the same thing with lists, and that's called list comprehension. And basically it's used the square brackets for the list. You put in a for loop in the list. You say how you want to generate each item in the list from the for loop, and you can also put in an if statement to if it's a conditional that you don't want every item from the for list, only a few of them. Okay, so I'll delete that now. Okay, so now by using region for time zone defined up here, we can just say, is the region for the time zone equal to region? And if we were doing that on the New Zealand-chat time zone, then we would get false, where before we got New Zealand-chat starts with New Zealand as true. And so this is going to work. The time zones for region New Zealand are not going to include New Zealand chat. So let's run this and see what we get. Solution 8. So time zones for region Australia. So there's the Australian ones, there's the New Zealand ones, the ETC ones, UCT, and then they're all the regions. So yes, the New Zealand one was correct. It doesn't include New Zealand chat. You'll notice also when I define these functions, I put this string here. I didn't store it in a variable. I just put it there at the beginning of the function. And what that is, that's called a doc string. And what that means is I can now call help on that function, and it will return it. So if I call help on region for time zone, it uses this this long string. So the string starts at this triple double quote here and finishes at this triple double quote here, and because they're triple double quotes, they can include new lines in the string. And now when I call help on it, it returns all that long string. So someone else trying to use my function can call help on it and see how it works. So that's a useful thing to do when you're defining functions. Here's a hint on time zones. When you're using ETC time zones, they just work opposite to the way I expected. Maybe you expect them properly. But so for Brisbane, it's actually equivalent to ETC/GMT minus 10, even though we're 10 hours ahead of GMT. So there's probably a way you can think about that logically in your mind. But it's not the intuitive one that I would come up with. Here's an example of calling help on the built-in function print. Okay. Right, now it's starting to get, it sounds like a bit harder now in our absolute beginner session. So once again, for the rest of the session, don't feel bad if you don't understand this, but I'll throw it in there in case you're feeling on top of things. We're going to start looking at how you can call functions with arguments. So we've been calling functions just by passing in an argument, but you can also pass in arguments by names, and you can also give arguments default values. So let's create a function total seconds that takes in some minutes and seconds and tells us how many seconds that is total. So you can see minutes and seconds are just our variable names as before, uses in the arguments, but we've put these equals 0 after each one, which basically says if they don't provide the value, assume it's 0. So how can we call this function? We can call it this way. We can call it just as before, total seconds, and then the two values, and the first one's going to be minutes and the second one's going to be seconds, and that's called calling by order. So it just uses the arguments in the order that they were provided. Now the other thing we could do is we can call it by name, and so we can say we want to have 15 seconds and 32 minutes. When you're calling by name, the order doesn't matter anymore, so I can put the seconds first and then the minutes second, and that's called calling by name. And then I can call it in but with a combination, so I can put the first one is a call by order, and then the second one is a call by name. Now if you're going to mix and match like that, then all your ones by order have to go first, and then once you've started using names, then you have to use names for all the following ones. So let's just check that that works. Yep, 32:15 gives us 19:35 total seconds. If we switch the order around but call them by name, we get the same answer. And if we call minutes by order and seconds by name, we also get the same answer. Okay, so redefine this task 9 using hours as well. Okay, I'm not going to do anything different to the provided solution, so we'll just look straight at that one. Total seconds, we've got 3 arguments now, hours, minutes, seconds, and we return the values. So in this case, we don't have to provide them all. We can call by order. So if we're calling by order, we have to provide the hours so that we can put in the minutes and the seconds. If we're calling by name, we only have to provide the seconds and the minutes. If we're calling by order, we didn't need to provide the seconds if that was 0, because its default value is 0. But yeah, so calling by name, we don't have to provide the hours. And calling by name, we can put in a different order. Let's just test them. And that seemed to work. So any questions as we're doing this? Okay, define a function which converts temperature in Celsius to Fahrenheit using f equals c times 1.8 plus 32. So I could just do define function of c, return c times 1.8 plus 32. And then we call f of 100 degrees Celsius, and the answer is 212 degrees Fahrenheit. So that's just creating a single argument function and returning a single value. Now here's a solution. I use longer names for my function and arguments, so that's always a good idea. And we'll put it in a loop and check the values for different values of degrees Celsius. So 0 degrees Celsius is equivalent to 32 degrees Fahrenheit. 100 degrees Celsius is 212 degrees Fahrenheit. And minus 40 degrees Celsius is minus 40 degrees Fahrenheit. Now if we want to expand this function so that it can take a temperature either in Celsius or Rankine to Fahrenheit, how would we do that? So I could define f here and say 459.67. And so F of 100 degrees Fahrenheit is minus 350. F equals R minus. So F of 100 degrees Rankine is minus 359.67 degrees Fahrenheit. Right, yes, all Rankine. So we can provide Celsius or Rankine. So we have to provide two arguments there, but they're only going to provide one. So these arguments have to be optional, and to have optional arguments you have to provide a default value. But the default value can be none. So let's do that. So we say if C is none, return R, else return C times 1.8 plus 32. So if I ran F of 100 now, that will assume it's 100 degrees Celsius. And so that goes 212 degrees Fahrenheit. But if I ran F of 100 degrees Rankine, then that'll give us minus 359 degrees Fahrenheit. Okay, but I haven't done any checking there, like we could have provided both. C equals 32. And that's given us the Fahrenheit equivalent of 32 degrees Celsius, but really not telling us why it's done that at all. So if we look at the solution, we see a better way of doing that. Say if Celsius is none, and if Rankine is none, then we raise an error to say you must provide one of them, else return Rankine, otherwise we do that calculation. If Celsius is not none, then we've got an else statement down here. First we'll check that Rankine's is none, because we don't want them to be providing both, in which case we can do the Celsius calculation. Otherwise we give them an error saying you must provide one of Celsius or Rankine but not both. Now when you run this is going to throw errors because we've raised these value errors. So I've put them in a try block, so try colon and then a code block, and I catch any errors that occur and print out the error. And that's just, I do that because when you're running these Jupyter notebooks, you sometimes want to go up to runtime and say run all. If you do that and it hits an error on the way through, it will stop at that cell. And so if someone wanted to run all those cells, this would stop there. But so if we're checking out three values of degrees Celsius, 0, 100, minus 40, three values of Rankine, 0, 100, and 459.67, and then we're going to try what happens when we call Fahrenheit with no values, and we get this error. There was a problem, you must provide exactly one of Celsius or Rankine. And you see that message has actually come from our function. It's not here. There was a problem, came from here, but by printing VE, the value error, we can see what the error message is that we got from our function. All right, now I'm going to show you one more data type in Python tonight. This is a lot you've had to learn, but this is another one of the collection data types. So we've done list, we've done tuple, we've done set, and now this one's called a dictionary. And the dictionary can store key value pairs. So you can see it uses curly braces just like sets do. But because the values in there have a key and then a colon and then the value, then Python knows that this is going to be a dictionary. So if I create a dictionary like this, I can print out the keys and the dictionary values. So D is the dictionary. D.keys gives me all the keys in the dictionary, and D square brackets key gives me the value of that dictionary. Okay, the difference between raise and return. Whenever you raise, you do for errors. If you want to throw an error, which is basically saying there's something wrong, you want the program to stop, or you, unless the person who's called your function is expecting the error, which if they were expecting an error, they would put a try and an except around what they called. You use a raise, but if they haven't done that, that will stop your program and will print out an error message. So you'd only use raise if they've really done something wrong and you want to stop the program, say no, that was wrong, stop here. It'll tell you exactly where the error occurred, and then they can look at that error and solve the problem in their code, so that that error doesn't happen again. Return is what you do in your normal run-of-the-mill. You want to return a value. So raise doesn't return a value; it throws an error. In which case, if you're in this try block here, and don't worry too much about understanding try blocks, but wherever you are in it, it'll jump out of it and go down to the except part of the block, and won't ever finish running the try block, but it'll do whatever you want to do in this exception. Now, if I was to do all of this outside, say if I was to call Fahrenheit, and I'm going to give it two values, C equals 41, oh, it's got to be full name, Rankine, so Celsius equals 41, Rankine equals 54, and I want to see what that gives me. And it gives me a value error, so ignore all this bit at the beginning. That was that's my try block. But here, everything after this dotted line, this is what happens to a value error if it wasn't in a try block. It goes, oh, there was a problem, and it gives you a trace back. It tells you where it came from. It came from line 15 on this cell. This is where it was, raising. You must provide exactly one of Celsius or Rankine, not both. It then displays what the result of that is there. And this is called a stack trace. So you can see you called this, which called that, which caused the error. So that's where you'd use raise to highlight those sorts of errors. But mostly you would use return to return values that are going to be used in the normal course of things. All right, let's have a quick look at this dictionary. So the dictionary looked like that. We can get the value from 10 as TEN, 20 is TWENTY, 30 is 30. So you can see I can use integers, I can use strings as my keys, and I can find the length of my dictionary has got 4 elements in it. Okay, now I had to give you a quick introduction to dictionaries because I'm going to show you how to use them with a star on my number of arguments. Now remember, before we did a single star to explode a list. Now if I do a star, it will take all the arguments that are provided and put them into a dictionary called keyword arguments. So we want them to only provide one value in our arguments here. It can be Celsius or Rankine, but not both. So therefore we want to check, is the length of keyword arguments equal to 1? If it is, then we find out what the key is. Have they said Celsius? Have they said Rankine? And then we return the value depending on that. Otherwise, we can check if they provided a different key. We can give them a warning message saying they gave us the wrong key. Or if they provided too many or too few arguments, we can say it accepts one argument, not, and that could be 0 or 2 or 3. And we've also displayed what the value of keyword arguments is in that case. Okay, so we're throwing different sorts of errors here so they can be handled differently. We throw a type error if they've, because that's what you would normally do, throw if they put in an argument that you weren't happy to handle, and a value error if they provided the wrong number of arguments. So let's run that. Yep, there was a value error. Fahrenheit only accepts one argument, not two, and it prints out what was provided. It was provided a Rankine and a Celsius. Okay, I'm running a bit late on time, so I'll just quickly go through this final task, how to convert it so that it takes Kelvin as well. You can see that this code would get very long if we were using the other way of doing it, but because we're using these keyword arguments with the double star, it's storing everything into a dictionary here. We can quickly check that there's only one argument. We can check whether it's Celsius, Rankine or Kelvin and display the result. Otherwise we throw these messages, and here's some code. We better define it, so I'll run that to define it. And then I'll run the cell that tests it. And you can see I've done all sorts of things here. I've called Fahrenheit with no arguments, and it's thrown the error message, only accepts one argument, not zero. I've tried it with two arguments. It doesn't like that either, not two. Shows me what the two arguments were provided. And I've put in the wrong type. I've put in bozos as an argument, and it says 100 bozos is equivalent to blah, throw an error, type error, Fahrenheit only accepts Celsius, Kelvin or Rankine, not bozos. Okay, so anyway, I encourage you to go through, do those exercises yourself, and then look at the solutions and see what you want. Feel free to ask any questions now. I'm going to sign off soon, so you're going to struggle to ask questions on YouTube chat, but you can ask questions on the Beginners Python Slack group. There's instructions on the Google and Meetup on how to get into that Slack group. Next week is going to be, the next 2 weeks are going to be machine learning, and they're going to be run by Arun. So make sure you sign up for them if you're interested in machine learning. And then that will be it for the year, and we'll be returning on the second week of January. So when we return, we won't have a absolute beginners in January, so the next absolute beginner session will be the first week of February, first week of February on the Tuesday. So I hope you enjoyed that. Like I say, keep asking questions on Slack, and also I'm happy to hear comments of what you liked and didn't like in the session. Goodbye.